let's get some practice taking inverse functions or finding inverse functions now. So let's start with f of x equals x plus 3 halves. It's a fairly simple function as far as functions go. So remember that to find the inverse, we want to take f of f inverse of x. We want to compose those two, the original function and its inverse, and get x. So in order to find the inverse of f, we can just do exactly this. We can compose f with f inverse. So we get that. And we want that to come out to be just x. So all we need to do is solve for f inverse. Well, that's as simple as subtracting 3 halves from both sides. So we get that f inverse of x is equal to x minus 3 halves. Now, either way I compose, if I take f composed with f inverse of x, or f inverse composed with f of x, what I want is I want to get x. So if I do that, if I take f of f inverse of x, I get x minus 3 halves plus 3 halves. Well, that's going to be x. If I go the other way, if I take f inverse and I put in f, I get x plus 3 halves minus 3 halves. Again, it's just going to come out to be x. So we know we've taken our inverse correctly in this case. Let's look at this second example now. We have g of x, which I've just named it something different so we don't get confused, is equal to 1/3 times x minus 2. So we want to take g composed with g inverse of x. So that's going to be 1/3 times g inverse of x minus 2. And we know that that's going to come out to be x. So in order to solve for g inverse, I can add 2 to both sides to start. So I can just look at this piece in order to solve it. So I get 1/3 times g inverse of x is equal to x plus 2. Now in order to get this 1/3 out of the way, I can actually just multiply both sides by 3. Because 3 is the multiplicative inverse of 1/3. That means when I multiply these guys, they're just going to become 1. So I get g inverse of x by itself on this side. This side, notice I do have a little bit of distribution I need to do. So I get 3x plus 6. So there is g inverse. Now just to double check, let's take g composed with g inverse of x. That's 1/3 times 3x plus 6 minus 2. Well, we just said 1/3 times 3 gives us 1, so we get just plain old x. 1/3 times 6 is going to give us 2, and we have our minus 2. So just like we wanted, we get just x. That tells us that we've most likely done this correctly. We've most likely gotten the right inverse. Now let's take as our function x plus 2 divided by 5. We want to find f inverse. So first of all, we take f composed with f inverse of x. So that gives me f inverse of x plus 2 all divided by 5. And the whole reason we do that is because we know we want this to be equal to x. So I can actually multiply both sides of this equation if I think about solving this part for f inverse. I can multiply both sides by 5. If I multiply by 5 on both sides, it's going to get rid of this 5 that I'm dividing by. Because that's really like multiplying the whole thing by 1/5, And again, I'm multiplying a number times its multiplicative inverse to get 1. So I have f inverse of x plus 2, and then the 5 on the bottom and the times 5 are going to become 1. So that's just equal to 5x. Now I can just subtract 2 from both sides, and I get 5x minus 2. So there we have the equation for our inverse, f inverse of x. Again, let's just double check. So I can take f composed with f inverse of x. So I get 5x minus 2 plus 2 all over 5. Well, minus 2 plus 2, again, I'm adding two things that are additive inverses, so I just get 5x plus 0 on top, or just 5x. And then I have 5x divided by 5. Well, that's just x. So again, we found the composition f of f inverse of x. We got x like we wanted. For our next example, let's take 3 minus 6x all divided by 2. We'll call it g of x. Again, we want to find g inverse, so we're going to take our composition g composed with g inverse of x. So we get 3 minus 6 times g inverse of x all over 2. And we want that to be equal to x. So if I focus on solving that equation for g inverse of x, well, I have division by 2 on this side, so if I multiply both sides by 2, this 2 and this 2 will become 1. 1/2 times 2 gives me 1. So I get 3 minus 6 times g inverse equals 2x. Now, from here, there are two different ways we could do this. So, one way we could do it is we could move the 3 to the other side. So I can subtract 3 from both sides and get that. The other way I could do it is I could switch where the minus 6 times g inverse and the 2x are. So I subtract this from both sides, I add this to both sides. So I get 3 minus 2x equals 6 times g inverse of x. So again, I added this to both sides, I subtracted this from both sides. So now, if I'm just going to go down and finish solving this one, I can just divide both sides by 6. And I'll get my answer. So I get 3 minus 2x all divided by 6. There's my g inverse. Now on this side, I need to divide by negative 6. Now, this isn't the exact same thing, right? They don't look exactly the same. However, I can show you. So I'm going to pull the negative 1 out here and write it as 1 over negative 1. Then this is really just the same thing as, indeed, negative 1. 1 over negative 1 or negative 1 over 1 are both negative 1. So if I multiply this on top now, I get negative 2x plus 3 divided by 6. So if I move around my order a little bit, I get exactly what we had over there. Another way you can think of this is I could factor a negative 1 out on top, and then that negative 1 and the negative 1 on the bottom would cancel. So that would look more like this. And we'd end up with the same thing when those negatives cancel. So we see that these are the exact same thing, even though they don't look exactly the same. to keep going with this one, I just want to double check, make sure that we have the right inverse. So, G of G inverse divided by 2, there's our G of G inverse. So the 6 here and the 6 here will cancel, they'll become 1. Then I have a negative that has to be distributed. So I have 3 minus 3, and then I have minus negative 2x. Well then I'm adding 3 and its additive inverse. I'm left with 2x over x, which is just x. So we're good. And we could have done the same thing with this one over here. They would have come out the same way. Let's look at one last example. Do just a little bit of graphing. So let's take f of x is equal to 3/2 times x. So again, we're going back to something a little bit more simple than what we had to do over here. So f of f inverse of x is going to be 3/2 times f inverse of x. And we know that that is equal to x. So we need to solve this equation. Oops. Putting too many f's in here. And I propose that if we take the reciprocal of 3/2 and multiply times on both sides, that these will actually cancel and become 1. So I get f inverse of x is equal to 2/3 times x. So both of those are fairly simple, right? They're both going to be linear equations or lines with no y-intercept because there's no plus b on either of them. It's just plus 0. So if we graph them, let's start with f of x. So we have a line through the origin with slope 3/2. So we're going to hit the origin, and then we can go up 3 over 2, and then again. So we get a line something like that. Again, not the straightest line in the world, but you get the idea. Then we have a line through the origin with slope 2/3. So we're going to go up 2 over 3. Let's do it in a different color. So up 2 over 3. Can do that again. Up 2 over 3. So excuse my imperfect line drawing here, but we get the idea that it's going to be a line that looks sort of like that. So here we have f of x, here we have f inverse of x. And what we should be noticing, and this will happen anytime we graph both an equation and its inverse, or a function and its inverse, is that we have a reflection over the line y equals x. And that's what we see here. If we were to reflect the green line over y equals x, or the f of x, then we get f inverse of x.